Hello guys, now let's try to solve the minimum cost for tickets. Let's see the statement. In a country popular for train travel, you have planned some train traveling 1 year in advance. The days of the year that you will travel is given as an array days. Each day is an integer from 1 to 365. Train tickets are sold in 3 different ways. A 1-day pass is sold for costs $0, and a 7-day pass is sold for costs $1. A 30-day pass is sold for costs $2. The passes allow that many days of consecutive travel. For example, if we get a 7-day pass on day 2, then we can travel for 7 days, day 1, day 3, day 3, day 2, day 3, Day 4, Day 5, Day 6, 7, and 8. Return the minimum number of dollars you need to travel every day in the given list of days. The example, given the days and the costs. This question asks us to return the minimum number of dollars. So this has the optimal subtractor. So we will think about use dynamic programming. Because DP is very suitable to solve these optimal substructure problems. But how to define the relation between the costs? Well, for every given day, we can see if we can use a continuous 7. If it can contain in the continuous 7 days, if we can contain that in the continuous 7 day before, then the total cost on that day will be the cost minus 7. Minus 7 plus that the cost 1, which means the cost for the 7 days, and the same if it can contain in the 30 days before that day. That means the total cost and that day will be the cost before the 30 days plus the cost 2, which is 15. And for a simple purpose, we can just use, because the days is fixed. We only have 365 days, so we just need a Boolean array to indicate if this day is a travel day. If it's a travel day, then we will calculate the cost. If it's not a travel day, we just maintain the previous cost. So we can define a travel day is travel day, and the size will be the 366, because we the integer from 1 to 365. So for simplicity, we will define one more, because the index from 0. And then we iterate the days in the days array, and then we will make a travel day equal to 2. And then we need a DP array. This array means what the cost ending that day. So the size should also be the 366. And at the very beginning, the day 0 should be 0. But we should, because we want to get a minimum cost, so at first we should fill this DP with the integer max value. And then, but the first day the cost should be 0. And then we iterate from 1, because the days are from 1, and less than 363 and I plus plus. So if today is not travel day, today is not travel day. We just keep the DP today will equal to previous day, and then we continue. But if not the case, we have 3 cases to consider. First is DPI will equal to minimum DPI and use DPI minus 1 plus the cost 0. What does that mean? Which means we just buy the 1 day cost. So we just use previous cost plus the 1 day parse cost. And what if what about 7 day and 6 day? If I minus 7 greater or equal than 0, we let DPI equal to minimum DPI and use DPI minus 7 plus the cost 1, which you use if we ending the day this day, if we buy us 7 days 7 day parse, and all the cost between among these 7 days should just be the cost 1, and we should add its previous cost, and we pick the minimum. But if not valid, for example, we just had like this one, we can buy a 13-day parse, but that doesn't mean we should wait all the 30 days. So even if it's not greater than 0, we can also buy it. So that will be minimum DPI, and we just use DP we just add this cost 1 because at first it's 0. So the same for the I minus 30 greater or equal than 0. DPI will equal to mass minimum DPI and DPI minus 7 plus this costs 2. And if not, we still can buy the 30-day parse. So it will be DPI and costs 2. At last, we just return the DP 335. Oh, sorry, forget for the new boolean. Sorry, the type should be int because that means the cost. So I don't know why I write boolean. Okay, thank you for watching. See you next time.